Welcome to the BioStock studio. With us today we have Anders Månsson, the new CEO of Phase Holographic Imaging, who is here to present an update regarding the company. The floor is yours, Anders.
Thank you. Welcome to the presentation of Phase Holographic Imaging, or PHI for short. So what is our company about? It's about high-quality cell monitoring using a technology on digital holographic microscopy, utilizing in turn a technology that we call quantitative phase imaging. And I'll tell you all about the technologies going forward in the presentation, but suffice it to say already on the first slide that it's about non-invasive four-dimensional cell monitoring, counting 3 dimensions in space and 1 dimension being time, for advancing cell-based research and cell-based therapies. I'll leave this slide on just as a disclaimer on forward-looking statements, but quickly pass on to the next slide. So a bit of an extensive explanation on who I am, as I just recently joined, is perhaps due. So I just joined PHI as the new CEO, but I do have substantial experience in the pharmaceutical and biotech arena with more than 30 years in large multinationals as well as in small startups. I have a pronounced international profile. I worked in all of the Scandinavian countries in the past and also worked out of the UK and Switzerland. And also in international roles, I've had the US as a focus market, but also Asia as focus markets. What's very pertinent about my profile is that I've run commercial operations in the past and I've also done a lot of M&A deals. And I think given the phase that this company is in currently, that is a very pertinent experience to have. So I'd like to start just by highlighting what one would have to believe to consider investing in PHI. And I would highlight the following points. That cell therapy will continue its inroads in the medical field. This is basically cancer therapy and stem cell therapy, but other regenerative medicine applications as well. One would have to believe that microscopy and cell monitoring and cell quality control standards and methods in this area will elevate up to the quantitative digital holography levels. One would also have to believe that some of the techie companies that pioneer this space scientifically can turn themselves into proper commercial companies, possibly also into partner or acquisition candidates. And one would have to believe that PHI could be one of those companies. And this is where the commercial profile comes in and also perhaps the M&A profile. And I'll explain more about Altium and the agreement that we have them in the coming slides. So let's start with the market. So this is a market research institute called Market Research Future, and they have this projection for the market. On the left side, you will see the projection for cell therapy. It goes from about $16 billion to over $30 billion in just over 10 years, or just under 10 years, sorry. And this is the underlying market that drives the market for the type of equipment that we're producing. So to the right, you can see their projections for the digital holographic microscopy market, which essentially goes from about just under $500 million to $1 billion in less than 10 years. So a doubling or more than doubling of the market. And this is the picture that another market research institute, perhaps appropriately named Maximize Market Research, as they are slightly more optimistic, they project the current market to be about $800 million, and they see this market as developing to a more than $2 billion market in the year 2030. So a slightly more optimistic view here. It doesn't really matter to me on whether you believe that the market is $500 million or $800 million. But the fact is that both of these institutes project a very rapidly growing market of a significant size. So, moving again to the slide, what one would have to believe, I would suggest that it is a proven fact that cell therapy will continue its inroads into the medical field, and that microscopy and cell monitoring and cell quality control standards will gradually elevate to the levels that we're able to produce. That leaves two questions then. Some of the techie companies that pioneer this technology will be able to turn themselves into proper commercial companies, and that PHI will be one of those companies. And this is what the rest of the presentation will essentially focus on. So let's take a step back and look at what PHI is all about. So we obviously have a vision and a mission statement, and the vision is to contribute to global health by supporting the advancement of cell-based therapies. And the mission more concretely is to facilitate high-quality cell monitoring through digital and AI-supported cytometry and cell imaging using digital holographic microscopy, or DHM. So what is it about digital holographic microscopy that is so special? Well, it is a quantum leap elevation of cell monitoring standards. It is able to produce high-resolution 3D morphology depiction of cells. It is also capable of producing long-term tracking of cell motility, which is movement of the cells, proliferation, and a slew of other parameters that indicate cell viability and health in the cells. And of course, since all of this data is digitalized, it is ample to be supported by AI for pattern detection and continuous improvement as the system evolves. And perhaps most pertinent of all, it is non-invasive cell quality control. If you use traditional microscopy, you typically take out a sample of cells from your production environment, which is already a disruption in its own right and has a certain contamination risk. You also label these cells with chemicals. And of course, then you would have to discard the sample of cells that you've taken out. This is not necessary using our technology. There's no labeling and no disruption, but you actually get 4D, 3D in space and 1 dimension in time cell monitoring. And as you see on this slide, you can actually measure a lot of things about these cells, including the circumference, including the volume, including the stretch of the area of the cell, its eccentricity, etc. And you get all of this data not only in the image format, but also in table format for further data mining later on. You might wonder how it works. Well, it is of course complicated, but I think in order to explain it in a simple way, we would have to get rid of one key aspect that might be prevailing in terms of a notion that the speed of light is constant. This might be something that you've learnt in school or in popular science books. But we have to correct that to some extent and say the speed of light is constant in a vacuum, but of course light slows down and speeds up depending on what media it goes through. And this is a fact that is utilized in our technology here. So our piece of machinery actually fires 2 laser beams. One goes through the cell, that's the sample beam, and the other one is a reference beam that doesn't pass through the cells. Now, as light that travels through the cells is slowed down somewhat, it is also phase shifted because light travels as a wave. And this phase shift interferes with the phase from the reference beam and creates an interference pattern that the image sensor sends on to the computer, whose advanced algorithms reinterpret these sensory input and creates this artificial 3D landscape of cells that you can see in this slide. So it's a fascinating technology. This is a view to what our product actually looks like in real life, and I think there are some pertinent items of information on this. First of all, it's not a medical device, which makes it easier to live with from a regulatory perspective because the only interactions with the actual cells is through the light of the laser. Our system is also portable, it's very versatile, it does a lot of different things and I'll show you later, and it's very easy to use, and it works with an external standard PC in a Windows environment. So the functionality is really there in terms of simplicity. Now, I would like to highlight, even though this is a very cool device with laser beams being shot, the defining functionalities of our product is really in the software. So this is what it can do. The software has basically 2 chief goals. One is to provide the actual and precise imaging of the cells. That is a given. But the other objective is also to provide to the user a user-friendly environment. And we do that in what we call our app suite. So along these slides, you can actually measure a few different things or a few different programs that you can start to be able to do your analyses. And this is the app suite. So we can, for example, do cell quality control, there's cell counting, there are different forms of kinetic analysis where you can measure and map out the proliferation of the cells. You can identify certain specific cells and measure their motility, so their movement. And you can also look at like wound healing and see how fast a wound can heal. So many, many different applications of analysis of cells and cell populations are possible from this app suite. And of course, you can also image specific cells and look at them in much the same way that you would do using traditional microscopy, only you get the images in 3D. So this system, this technology allows you to do really, really intimate analysis on your cells. So on the left of this slide, you will see the overview of cells, and the system has an automatic cell counter. So you can have your cells counted automatically. And this feature is something that is also available in traditional microscopy, but you can, of course, move further with our system and look at individual cells and also see the areas of the cells, the volume, the thickness, the texture, and the irregularity of the cell shape. So this really adds something to the investigator of cells, adding the third dimension and adding all the parameters that come with that. So if you compare traditional microscopy to what we have, traditional microscopy is flat, it's 2D. You have to use chemicals in order to have the right level of contrast to see the cells, and that of course is provided for by chemicals. So you add chemicals to your cells, which means that you have to discard them at a later time. And obviously this taking out a sample from the cell population is disruptive in its own right. You take out the cells from its 37 degrees Celsius environment, and that of course also affects the cells, so you might introduce an error of measurement right there. Instead, our technology allows cells to be monitored in their production environment without disruption and without contamination risks, and you're able to get these fantastic measurements on the cells, both as individuals and as regards the cell population as a whole. So what we have in terms of the product is not just a microscope, not even just a microscope plus. It's a smart four-dimensional cell monitoring systems able to watch and to study cells in 3 dimensions in space, and over time adding the 4th dimension. It is label-free, so you don't have to use chemicals. It is cell-friendly. You put the scope inside the production environment, inside the incubator, rather than taking cells out of the incubator. You can measure the individual cells. You can see at the bottom left-hand corner there, cell tracking, so you can see how individual cells move in the population. You can do this in a more graphic scale and look at how individual cells multiply or reproduce, and at what time and what happens to the cells that they have reproduced to produce. You can look at assays like wound healing and see how fast it goes. And the system is very compact, and it works on a standard laptop in a standard Windows solution, making it also very affordable as an entry-level system into QPI. Why is this so important? Well, with the emerging market of cell therapies, it is going to be increasingly important to be doing testing on the fly here. So you might want to test your cells when you take them out of the patient. You might want to test the cells when they're in production. You might want to test your cells in transport, and you might want to test your cells before injecting cells back into the patients. So testing of cells and testing the viability of the cells will be ever more increasingly important given the emerging market of cell therapy. Now, PHI is obviously a rather small company, but we have relied on a vast network of institutions and companies in regenerative medicine to do great things. And one thing that the company has done extraordinarily well, in my opinion, is to get global customers to publish on the basis of the experience they have with our system. So we actually have more than 300 publications on our technology currently, and that, I think, is more than any other company in this technology area can boast. So in summary, We have a key technology and a proven track record in this very important area. We have strategic partners and academic collaborations with the very most prestigious institutions in this arena. And we have an emerging market which has a great potential. And the novelty that we've added recently is that we've added a partnership with Altium as our global distributor. Altium works as our distributor in some markets and has an alliance that works in other markets. But essentially it provides one sort of speaking partner for our entire sales and marketing operations. And Altium is also our largest shareholder. So that is a semi-virtual integration, if you like, that provides to PHI a sales and marketing machinery that it has never had before. And this is also making a significant difference in sales. This year we are forecasting 100% sales growth, and that I think makes a huge difference to the company. So again, coming back to where we started, what one would have to believe in order to consider investing in this company. Again, that cell therapy will continue its inroads into the medical field. Again, cancer therapy, stem cell therapy, other aspects of regenerative medicine as well. That microscopy and cell monitoring and cell quality control will be driven by this market growth in cell therapy, and that quantitative digital holography levels will set the new regulatory standards in this arena. That some of the techie companies that pioneer the space can turn themselves into proper commercial companies, and that PHI is one of those companies. And again, this is where I highlight that my coming into this company is a coming into this company of a person with significant commercial experience and also M&A experience. And that is coupled with the fact that we now have a semi-virtual integration with Altium that has us have sales rep boots on the ground in pretty much every country in the world where there is a market for our technology. And with that, I thank you very much for listening, and I hope that you will be enticed in your interest in PHI.
Thank you very much, Anders, for an interesting presentation on the company. You actually presented on a couple of alternative growth scenarios for the digital holographic imaging market, reflecting the sort of the long-term potential, if you will. But what do you consider the key factors for PHI to become successful in the short term?
Yeah, that's a very good and important question, I think. Yes, they were slightly different projections, but they were both projections of a very quickly growing market and also starting at a significant level. I mean, I don't really care if it's $500 million US or $800 million US. There is a significant market there, and we need to adapt to that. What is most important in doing that is realizing that we do have a product on the market. And yes, I understand it's interesting to talk about the next model and the next model, but I think it's really important that this company now realizes that it has a product on the market, and its first priority needs to be to support the sales of that product. And yes, Altium has a large responsibility, but we need to guide them in providing a reasonable market analysis, a good positioning for the product, and training and support as much as we can.
And you outlined the advantages of non-invasive cell monitoring. It seems very compelling, and you do also have a growing number of use cases to sort of validate that, and publications in scientific magazines and so on. But having a product on the market, as you say, is crucial. But do you think that this market is the momentum moving faster towards sort of the new technology in advanced cell monitoring, or is it a more slow and hesitant market, you'd say?
I wouldn't call a market that will more than double its size in just under 10 years a hesitant market. I think it's a phenomenally fast-growing market. So I think, again, to your first question and my answer to that one, supporting sales in the current market with a current product has to be key for us. And that's a job that we need to do well, because that will be crucial to realize and to generate the revenue flow that will fund the development for future models.
And then the preclinical market, that's your top priority in increasing the sales and so on. How do you plan to just further penetrate that market?
Yeah, again, by supporting the sales of our current product in the current market, because our current product, let's face it, is suitable primarily to the preclinical applications of it. It is a small yet versatile, really, really good, affordable type of model that might be the first model that you get into the QPI segment with. And yes, we want to develop further and we want to go into the clinical segment as well. However, I do think that needs to happen with some sort of collaboration with a larger company in order to be realistic for us. But again, the first priority is to support the current product in the current market, because that's really big and it's growing really quickly.
I understand the need to focus on first steps first, yet it's still interesting to talk about the future and having this ongoing evolution then of cell-based therapies. It's partnerships the way forward and for you to position PHI to fully tap into that development using your technology in clinical settings or clinical applications then?
I think it is. First of all, it's difficult to do a lot of different things. If you're a small company, you have to prioritize your resources. The product that we have developed currently, I think, is excellent for the preclinical segment in that it's versatile and it's really easy to use. And it's really small scale. You can fit it into any incubator. And all of these are great advantages in the preclinical setting. If you take the other extreme and go to like clinical production, the qualities of a system that would be valued in that sort of a setting is probably large scale and high degree of specialization in doing only one thing. And that's not a system that we have currently. However, we are, as I alluded to in the presentations, something like thought leaders in this area because we have more than 300 publications. So we certainly have the software development technology to aid also the clinical area. However, I do think from an investment perspective that will require a large-scale collaboration with a larger company. At least that's my guessing currently.
And speaking of investments, one of the buzzwords that lately have been attracting lots of interest from investors, that's AI. And you actually managed to squeeze in AI in your presentation as well. So apart from it being a buzzword, how do you envision AI to possibly improve this the functionality of HoloMonitor going forward?
I think there's endless opportunities to do this, but of course you have to start somewhere. And the first very concrete thing that I think we need to do is to apply AI to allow the system to become even better at what is called cell segmentation. And that is to be able to differentiate between one cell or two cells or three cells if they're sort of layered on top of each other. And obviously we have fantastic mathematical algorithms to do that, but it's not perfect. And nothing is ever perfect unless you train to be perfect. And I think AI or machine learning, more accurately perhaps, is a tool to be used to make the system even better at distinguishing between like one cells or two cells, for example. And that is the first applicability of AI. But of course, we generate a lot of data with our system. Further on, you could think about applications such as recognizing very early different sort of proliferation rates or different sort of cell viability patterns in the data that would allow you to perhaps stop an experiment or redo a setting of the experiment at an early stage so that you optimize the cell population growth or whatever sort of assay that you're trying. So there are limitless possibilities to the applications of AI because we are really a software-based company generating loads and loads of data with our system.
So there is definitely potential in the future as well. But looking at the short term, the very short term, this year is quickly coming to an end. And what will be your personal main focus now before the books are closed for 2024, apart from closing the ongoing capital raise in December?
Right. So the ongoing capital raise is, of course, the key focus until the end of the calendar year. And that will also mark, I think, a first sort of honeymoon phase for me, where I've mostly observed the company and taken stock of where we stand and what we need to do. So come next quarter, I think I will be more directive in the approach. and perhaps change some things in the company and how we do things. And also, we are operating not on a calendar year as our fiscal year. So our fiscal year actually ends only in April, and that means that we are yet to receive some record-breaking orders from Altium in the coming months, reaching, as we have projected, a 2 million euro turnover in this fiscal year, which is twice as much and some versus previous years.
So plenty of time to keep pushing those limits and improving the numbers then. Thank you very much for taking the time today, and we of course look forward to following your results going forward.
Thank you so much.